Okay, so I'll start meanwhile. So that was a pretty insightful talk on how to make the content in AEM crawl ready. With this talk, we'll expand it a bit further and see how we actually add that intelligence and what we do with that content in AEM. So, Content AI. Quick introduction. I'm Nitin, and with me I have Fabrizio. Both of us are developers at Adobe and Oak committers with the focus on search and indexing. So, what do we have on the plate today? We'll start with a brief overview of what Content AI is and why the need for such a solution. We'll then talk about the architecture in detail and the services that form this solution. We'll do a couple of demos for the main use cases. And then towards the end, we'll talk about what's in the pipeline in the near future. Okay, so the overview. Before getting into what Content AI is, I'd like to address why the need for such a solution. Over the past couple of years, LLMs have changed how content is being created and discovered. There have been a lot of toolings that have come in for organizations to make use of the various AI use cases. But at the same time, they also face growing challenges because their content lives in various sources. And due to this, they are unable to leverage these opportunities to their optimal potential. And ultimately, this leads to an inconsistent brand representation. So, to address these core problems, we need to understand that content is the key. And to provide a scalable solution to these, we need to manage this content layer efficiently. And this is where Content AI enters. The idea at its core was very simple. We have the content in AEM. Why not make it intelligent and unlock these various AI use cases? But we didn't stop there. We added a lot of services which ensure that content from even other sources, external sources, could also be ingested into this same layer. And then on this aggregated pool of content, we do various transformations and enrichment. And the result of this is a semantically intelligent and unified content layer. This, with a scalable retrieval engine, leads to powering multiple AEM capabilities, improving the out-of-the-box features and facilitating new ones. And staying true to AEM, this would be available to developers for various extensions and customizations. Okay, so after having understood the need for Content AI and how it aims to solve the problems described, I'll now take a moment to showcase what is Content AI, not a blank slide. So it's a collection of different components and services that together aim to enable various AI-based opportunities. I'll introduce these components one by one. So at the core, as I mentioned, is the content layer. The AEM content plus the content source from external sources, all enriched and transformed, and then made suitable for an efficient and scalable retrieval. Then we have the AI search or the semantic search. This component basically provides various types of search capabilities like hybrid, full text, and some other features as well. We'll talk a lot more about this in detail in the upcoming slides. These two components combined ensure that various RAG-based use cases can be enabled on top of the content in AEM. Talking about RAG, then we have the out-of-the-box generative component for Content AI answers. This can be used by organizations to create generative responses for user queries. And then we have something that's called configuration or the admin APIs, which basically are used for onboarding, managing the configurations of this whole setup, ingest external content, etc., etc. And then we have the ML models. These basically comprise of the embedding models that are being used for enrichment, enriching of the vector, the content layer in the middle, and then also the LLMs that are used for the generative responses in AI answers, plus a lot of internal toolings that are used for ensuring the quality of this whole system. Okay, with that, I'll now hand over to Fabrizio.
Thank you, Nitin. Hi, everyone. I recently came across a report from Gartner about rethinking enterprise search to power AI assistants and agents. I think it's a really interesting report. It was published in April. What struck me out was that how closely their perspective and recommendations aligns with what we have built with Content AI. Our approach starts from the same premise. Basically, we think that AI assistants and agents, to succeed, need to be powered by a reliable search. And moreover, when we think about search, in many organizations, search is seen as a thin layer on top of your content with some UI. We need to change this. We need to treat search as an infrastructure, as a platform. We need to have a system of delivery. We need control. We need connectors. We need, as Nitin said, tool to evaluate, continuously evaluate the retrieval, the quality, and so on. To make this concrete, let's walk through the architecture journey behind it. So let me start by saying that we did not invent a new platform. We decided to build it on top of the existing search and indexing infrastructure, which is powering AMS cloud service at massive scale. Let me take a step back. As you all know, most of the indexes in AEM are materialized in Lucene and are embedded in the instances. As Jörg explained this morning, elasticity, it's a very important property, and instances can go up and down pretty frequently in AMCS. So what we have done in the past few years, it's a quite critical shift. So we put a new layer on top of this, which we call remote search, is powered by Elasticsearch. And from your point of view, this is mostly transparent. It means you can still use the same index definitions. You can still use the same JCR queries. And regardless if the indexes are materialized in Lucene or Elastic, nothing changes. And while we were doing this, we noticed that there were new possibilities coming from this. So first of all, this improved a lot troubleshooting. Indexes are not black boxes anymore. We can look into the indexes. We can troubleshoot them easily. And then we said, wow, we can look into the indexes. What if we build applications on top of them? And here is where Content AI was born from. So we have introduced a layer to handle enrichment, to handle semantic search, to do generative search, and a lot of other toolings around it that we will touch in a second. So let me zoom in some of these components. How do we get content in Content AI? So as we said, the content we care about is mostly in the AEM repository. But what if we want to expand this intelligence on content that is somewhere else? It can be a partner website. It can be a legacy system. And here is where the acquisition component comes in. You can configure it through the admin API to pull in semi-structured content, and you can configure scraping, crawling, API feed, and there are more connectors about to come, and push it straight in Content AI. So the key here is that we don't want to limit the intelligence to what's inside AEM. We want to make also external content first-class citizen. And we think that the combination of the AEM repository plus this external content, all lifted together in the same intelligent layer, can can unlock the next generation of AI workflows. Now the content is in the system. We have other two components here. Indexing and ingestion are mainly used by acquisition, the acquisition service, to do the basic stuff, to handle the indexes, to update the configurations and so on. Where things get really interesting is in the enrichment. In the enrichment, we have pipeline configurations. As you will see in a second, this might look very similar to index definitions. But there is a key difference here. Enrichment pipelines are index-centric. That means that if you want to change something, or you have a new use case that you want to cover, and you change the pipeline configuration, you don't have to go back to the original content. You don't have to go back to the AEM repository or the external source. The original content lives in the indexing layer, and we can reprocess it. And this makes the system very flexible, very efficient, and it makes a lot easier to evolve as the needs of your search and AI use case change. Let's have a look at an actual enrichment pipeline. We have concept of spaces. In here you can see what is a vector space. A vector space contains transformation with the goal of producing embeddings. In this example, we have two vector spaces with two pipelines. They are working on the same input, which is the description. And we are generating embedding from the description using two different models. In red, you see Hugging Face Mini-LM open source model, and in blue, we use ADA002 from OpenAI. Why do we want to do that? Several reasons. We want to run an A/B test, or perhaps we want to cover different use cases that might benefit from different models. One model might be good at short-term queries, while the other model might be better at capturing wider semantics. Then we can also define lexical spaces, and here is where the similarities with index definition are very close. In this example, we have a JQ expression to concatenate title and description, and we want to use it as full text. We can also add other parameters. We can configure analyzers and so on. The key here is to keep these spaces separate. So we can use them, as you will see in a second, in the search API, depending on the problem that we are about to solve. And now, let's turn to the search service. This is the component that actually makes the intelligence usable. At its core, it supports multiple search styles. So we can do hybrid queries, we can do hybrid searches, composing KNN, K nearest neighbor semantic retrieval, with the good old-fashioned filtering and full text capability we relied on for years. That means you can get relevance based on semantic, on the meaning, and the precision of filters. Another key aspect here is that we are not limiting the search to a single index. You can run queries across multiple indexes. And here is where things get really powerful. The enrichment pipelines you have seen before are not just used for configuration. They are part of the query surface. Basically, you can tag a query. You can say, use that model, use that vector space, and you can combine them. That makes A/B testing trivial. You can run this stuff in production with different configuration. You can monitor performance. You can gather feedback, and then switch to the best setup with confidence without re-architecting the system. All right, now let's see an actual query. As you can see, the search API is composable. You can mix and match query types depending on the problem you're solving. In this case, we have an hybrid query that uses a vector part using the Mini-LM model, plus a full text part that uses the lexical space we have configured before. And that's the sort of setup you would like to use for a site search, where you want to have both semantic relevance plus the precision of filters. And here we have another query. In this case, it's a pure vector query. And notice the difference here. We are not interested in the original documents anymore. We are asking for the most relevant chunks. And that's exactly the pattern you would like to expect in a RAG workflow, which Nitin will dig in a second. The key takeaway here is that the same content can be lifted into multiple representations. And those representations can serve very different use cases, all from the same indexing layer. And now, let's do something practical. All right, this is the assets view. We all know that AEM search is good at looking for terms, but not for meaning. So what happens if I search for big passenger ship? All right, I get 3 relevant documents back, right? And what if I want to extend this query and I search for big passenger ship on water? No results. Why? Because our metadata don't mention these terms. Yes, you can improve it. You can improve the relevance. You can add stemmers, tokenizers, synonyms, and so on. But it gets quite complicated, right? And now look what happens when we enable semantic search. We see cruises, large vessels, ships, and so on. Exactly the kind of thing we were thinking about. And it gets even better. So we're in Berlin. Let's try the same in German. Again, traditional search, no results, because our metadata are in English. But when I switch on semantic search, we get relevant results. Because we are not looking for terms anymore, we are looking for meaning. And this is a big step, because in this case, the search is just the interface that you are seeing. The search is the experience. But the good thing is that you can use this as part of your JCR queries or through the open API you will see in a second to power your AI workflows, as Nitin will show in a second.
Okay, thanks, Fabrizio. Okay, let me move back to the slides. Okay, so now we'll talk about AI answers. This, as I talked about initially, is the RAG-powered generative response service that Content AI provides out of the box. It can be effectively used by various brands to enable generative responses to user queries for better engagement. This is quite a feature-rich service. It consists of dual response modes to cater to various UI requirements. It is highly customizable. Brands could customize the prompts and ensure that the responses are in line with brand's guidelines. There's contextual metadata processing via which you could actually get responses tailored to a particular context, which I'll demo in the next slide. It gives you citations, follow-up questions, and there's an option for users to give feedback, which flows back into the system to iteratively improve the responses. What's interesting here is that Content AI and its suites of services, using this, it will be very easy for any AEM customer to enable this feature on the existing AEM content without any integration effort as such. Okay, now after having talked what AI answers is, I'd like to revisit this architecture diagram again to show how the data actually flows in through the system when we use AI answers. So as soon as a user enters a query in the AI answer search UI, that query along with the metadata that is sent by the client is sent to the AI search engine, which Fabrizio just talked about, to get the relevant chunks, in this case, from the website's content. These chunks, then are combined with the brand prompt, some other guidelines, and then sent to an LLM to get the response, which is then shared back with the user. During this process, there are guardrails present at all the input and output gates to ensure that we do not process any harmful content. And then once the answer is visible to the user, they send the feedback, which again flows back into the system, as I mentioned earlier. And it is used then to iteratively improve the service as well as the tenant-specific configurations. OK, so with that, I'll now move on to the demo for AI answers. OK, so with me over here, I have inside Adobe. This is an internal portal for Adobe employees, and it was the first internal customer to go live with AI answers. Before this, there was this search bar that used to do a simple lexical search, where any user queries would be matched in a lexical manner to the site's content, and any matched pages would be shown up as links. While this works for small keyword-based queries, as we all already saw in the assets demo as well, but for complex queries where we want to find the intent of the user, it doesn't work. And also, in the old traditional way, one would actually have to go through all the links, read them through to find the information that they're looking for. Let's see how AI answers actually changes that. So let's say I want to search for some parking places in my office. I just simply ask where to park and wait for the response to come up. OK, so as you can see, I get the generated response detailing the various parking spots in both the offices in Noida. So the context that was sent along with this query was the location that is sent in my user context over here, and the answer was accordingly created based on that location. And if I just expand this, here's the feedback that I was talking about. In case I don't like this answer, I can simply do a thumbs down, provide the comment why I don't like this answer, and it will flow back into the system. I get various related questions over here that I can try out. But what I want to show now is what happens if I actually change this location. So let's say I change the context to San Francisco and ask the same question again. And if you now see, the answer now is getting generated with respect to the San Francisco location. So that context work. In this case, it was the location, but different contexts can be wired in, and accordingly, the answers for the same query would vary. Okay. Now, to show the multilingual use case, right? I asked the same question now in German, and as you can see, I get the same answer correctly, and there was no additional effort required by the developers of inside Adobe to enable this. So you just enable AI answers, and multilingual search is enabled by default. OK, so after that, I want to show a couple of more use cases. First, to show how the answers are actually grounded in the information that is sourced from this and this site only. Use case which the last presentation also mentioned. So let's say I answer a question, how to connect to Wi-Fi. Now this question is very generic, but as you can see, the answer is not. It's not any answer that is just source of the web, but it's rather very related to Adobe. It's picked up from the knowledge that the system derives from the content of this particular site and answers accordingly. OK. So after this, the last thing that I want to show is the guardrails that we have in place. I ask a considerably harmful question, how to plan a DDoS attack. And yeah, it doesn't answer, it will filter it out. It is highly customizable. You can put in various guardrails and ensure that the system is not compromised and it does not give out any random answers. OK, so that was the demo. I'll now move back to the slides. OK, so how can you guys try it out? At this point, these services are exposed as experimental APIs. This is the QR code. While I go through the slides, you guys can have a scan, get a look and feel of these APIs. And in case you want to discuss about these further, tomorrow me and Fabrizio would be in the Meet the Expert session, and we can talk about it in more details. So these APIs are Open API compliant, and they have been roughed out with a few internal customers as well as other Adobe solutions as well. At this point of time, we are engaging with more early adopters for them to be able to leverage the benefit of Content AI services. Okay, so now I talk about what's on the pipeline in the near future. Okay, so first of all, Content AI on oak indexes. At this point of time, we have a couple of oak indexes which are already leveraging Content AI using the semantic search. The assets index in the previous demo is an example of that, where it's using semantic search to get assets in a better way, retrieve assets in a better way. Going forward, we intend to work on integrating more and more of oak indexes so that this can effectively empower developers to build a robust site search solution on top of the JCR content, along with content sourced from external sources as well. From a cloud service perspective, this would entail a very seamless integration when enabling any features from Content AI or from other AEM solutions that are leveraging Content AI at their core. Next, we'll have the evaluation pipeline. As I talked about in the AI answers slide, there's a feature to get the user feedback. And once this feedback flows back into the system, what do we do with it? It will start feeding up this evaluation pipeline, where it will be taken into account to iteratively improve the service as well as the tenant-specific configurations. It will not only evaluate the system from the response quality perspective, but also aid in performance profiling and safety check evaluation. Towards the end, I would like to highlight that there are various AEM solutions that are being developed with Content AI at their core. To name a few, there are Content Hub, Sites Optimizer, LLM Optimizer, Generate Variations. They have tested out with Content AI in various capacities. And most of these target to ensure that AEM customers can effectively utilize these various AI opportunities and use their existing AEM content to build those. And Content AI is enabling them to do that in a seamless way and at scale. Okay, with that, we wrap this up and we'll take questions now. Thank you.
Thank you. So, brought some cash questions. First one, will AEM as a cloud service customers be able to expose Content AI semantic search on published content to website user as a page search and as a public API search for the published content?
So AI search will be available through Open API. This is the plan at the moment. So, and it works both on the author and published tiers, because it's based on the OAK indexes, and we have several indexes on author and publish.
Is direct data used by Content AI permission sensitive, so that you just see what data you are allowed to see?
Yes, it would be. So in the retrieval, we would take care, we're taking care of the authorization. There would be cases where anonymous access would be there. For example, site search, where public site, whenever we are scraping any public sites to ingest the content, that would be available anonymously. But at the same time, if there is content that is behind ACLs in AEM, the same thing would propagate to Content AI as well.
Seen the nice thing about searching the boats and vessels. Will it also be available, like semantic search, like for example in the asset selector?
It's actually one of the project of the team we are working with to enable in the asset selector for both assets and content fragments.
Okay, cool. Is the ingestion of indexing in edge delivery to enrich search, the enrich search type of use case you're planning on handling?
It's something we are looking into. Nothing planned at the moment, but it's something we are looking into.
Thank you.
You're welcome.
Great to have you on stage.
Thank you.
Big applause.